It's 9:30, so let's get started. Good morning, everyone. Welcome to the RTGWG session. I'm Yingzhen Xu, and I have my co-chair, Jeff Tansoro, online with us. And we do have a full schedule today, so let's go straight to the point. One thing we need people help with the note-taking. We use the hashtag, so please help and contribute. Jeff, you want to do the status?
Yep.
And do the share.
Welcome everyone to Bangkok and online. Happy to see you. Supposedly it's very warm in Bangkok. Too warm. Next slide.
You have control.
Yep. Not well. Please make sure you read not well. You get yourself familiar with IETF policies and how your work is treated when you contribute to IETF. We didn't have any new RFCs since IETF 121. We adopted IPv6 address resolution young model. Really good work. We've submitted 7 route LFA after years of going back and forth.
Yeah.
It's an RC editor queue, and we really want to thank everyone, and specifically Engine, to put in so much energy, sending emails, bribing. I don't know what she was doing besides this to get this done, but we're almost there.
Yeah, finally, this one is in RFC editor queue, so yeah.
So BGP peak, we received many comments, so there's more work need to be done before we go into second working group last call. And we have requested a young doctor review for VRRP. Point-to-point BFD, I'm co-author, so I'll let Engine, but we believe it's ready for working group last call. Point-to-point BFD for VRP will be discussed today, and net to cloud. I mean, it's not entirely surprising. It has been returned to working group. It's going to be discussed today again. So IPv6 address resolution and ARP are going to be discussed today. QS model, there's review comments that need to be addressed. We know how difficult it was to get there. Thank you. And multi-segment SD-WAN, there's larger discussion on SD-WAN related technologies in general. We welcome you to review it. Again, before we go into working group last call, it's getting there, but we believe there's more reviews, more work needed. And then source routing revive, the draft, the original one was pretty much ready for working group last call. So we believe we should go into last call. Again, please review it.
The destination source routing draft, I communicated with the authors, and there are something new pop up in the V6 ops. So they wanted to add something about operations. So the authors, please do that. And people are welcome to review it.
So busy agenda today. So please try to be on time. Don't push people who come after you out. And I think we are ready for the first presenter.
Okay. Now let's go to the presentation. Linda is the first one.
Good morning.
Hi, Linda.
Hello. Nice to see you. So this is the old draft. Has been going on in the working group for many years, actually. I'm so tired of this at this moment right now. But anyway, so this I just gave you the highlight, the summary of the discussed points on the resolutions and the major changes. Summary of the major changes. So basically, during the IESG review, there were comments from John, Ganta, Eric, David, and SEC and directory. There are quite a few comments about the scope of the document and intended audience, because we talk about enterprise connecting to the cloud edge, and there are many, many, many issues, and it is impossible to cover everything, and especially in IETF, this document is really just target at potential work that can be done in IETF routing area. And the purpose of this document is really to have the framework to glue together all the drafts and proposals in various working groups, which include IDR, which include IPsec, because one of the key point of the SD1 is using the IPsec to interconnect all the edge nodes, and using IPsec, the iKey v2, it just doesn't scale well. So this document the gaps and the potential work, and point out to other proposals which are being proposed in different working groups to address those issues. And um, also emphasize that whatever documented in this draft is for information only, just for people who want to see what kind of IETF work has been done to address the enterprise connecting to the cloud. Not doesn't mandate those drafts to be adopted or being published, really for the information only. There's also reference to the other SDLs like MEF and 3GPP on the edge cloud. But the work is really for reference only, just to give people a background where the problem is, and there are other documents in other specified by other SDOs, define the scenarios, requirement, and we are just taking that. Is for reference only. It's really for the purpose of the work to be done by IETF routing area. So those are the major changes in version 42, and I hope people can review it again. There are many emails with each individual resolutions, but I'm sure it's too much for people to go through. But just review the document, see those issues being addressed. Here's some specific discuss points I want to point out. And just reiterating that in chapter 1, we discussed the purpose. Here's the paragraph. We put it in chapter 1. And for the security consideration, we also put in that security consideration is really for the networking part, for the routing part, not for specific patch or cloud management. And we also removed all the vendor-specific product references from the document. There's another part about the BGP peering, because as a cloud gateway is peering with many, many more parties than traditional network service providers. They frequently encounter issues of routes overflow. And here we have there's a chapter 3.1 describe the recommendations and mitigation practices, best practices to mitigate those issues. And there were comments about some of the operational risks of the route overflow. So we have revised that as well. And for the fault detection, because within data center, sometimes IGP is not running, or they may run proprietary fault detection. How do we escalate those, propagate those faults to the remote edge nodes? There's discussion on the scenario and the gaps. And then we also improve the clarity for the 5G edge cloud. So, and we're hoping for another working group last call and looking for people to review the document. Thank you.
Do you think we need another round of directorate reviews?
That would be great.
Yeah.
Thank you.
I can request that.
Thank you.
And
So, any other questions? If not, we can go
Okay.
to the next one. Okay, so this is the multi-segment SD-WAN. And next page, please. Oh, I can do it, sorry. Okay. Okay, so the purpose, the problem domain of this draft is to address the using cloud backbone to interconnect campus branches which are far away from each other, instead of having like traditional SD-WAN or IPsec um, paths between like A and B. If A and B are very far away from each other, and A and B each have their connection to the nearest cloud gateway for their services instantiated in the cloud. So they already establish like SD-WAN segments, like different overlay, different underlays to the cloud gateway. So the purpose of this draft is to how do we stitch together different SD-WAN segments in different locations through the cloud backbone. With this, you can provide more reliable connectivities. You can predict that the cloud backbone can provide more reliable connections and also can provide services of like network function services, integrated network function services, and they can impose threat intelligence for those traffic, even though they are encrypted between A and B. Through the cloud gateway, they can enterprise can dictate explicit pass nodes or explicit exclude some nodes or include some nodes to give some predictability of the path from one location to another location. So that's the background of this. So here is a more simplified picture showing from A to B, there's IPsec encrypted traffic from A to B. Instead of just sending to the internet to A and B, here we want this to A, traffic goes to the nearest cloud gateway, and then indicating to the backbone how you want this traffic to egress. Like for example, you can indicate the egress from gateway 10, which has B directly attached. Um, so this is basically the scenario for this draft. Um, so in this draft, we propose to use Geneve, a new Geneve option class to indicate to the cloud gateway that this traffic is encrypted and the purpose is not to be terminated at the in the cloud. And the purpose is really for the cloud backbone to forward it to the egress. Within this, quite a few sub-TOVs is proposed. The enterprise can indicate where they want to egress the traffic, or they can let cloud backbone to determine where is the optimal egress point is. So we propose using Geneve to do this job because lots of cloud providers do support Geneve encapsulation. Here are some of the sub-TLVs being proposed in this draft. There's one for the target endpoint, where's the endpoint destination CPEs, and there's one sub-TLV to indicate the original source CPEs. And there's sub-TLV to indicate I want to include specific nodes to reach my egress cloud gateway. And there's also sub-TLV to exclude, like you want to exclude certain regions, certain countries, you can indicate that as well. So here's just a picture of the data plane. So what it is on the bottom part is the original payload from A to B. And we add the top Geneve header with the new option class to indicate the purpose. And we also propose to add authentication TLV to for the gateway to be able to authenticate this packet, only the packet header, make sure this is not tampered, or make sure there's no man in the middle attack. Here, just the general process at the gateway, ingress gateway. Basically, ingress gateway need to authenticate the header, make sure this packet is not tampered, and then checking if the egress gateway is there or not. If not, it can search themselves. Once identify the egress gateway, it change the header so that they can forward it to the egress gateway. How they forward it is beyond the scope because each provider may have their own way to forward the packet within their backbone. Similarly, at the egress gateway, the things egress gateway need to check, make sure the source is the validated ones, and to prevent any unauthorized traffic coming in, ensure the cloud gateway that the destination is provisioned, is not random destination. Then it will forward the IPsec payload to the CPE. For the control plane is utilizing the IDR's SD-WAN Edge Discovery proposal, the proposed mechanism to achieve the exchange of the IPsec or WAN information. And there's another proposal in the IDR for the CPE's closest gateway exchange. And there's also a proposal in the IPsec ME on the key management, because when we do the authentication between CPE, remote CPE to the cloud gateway, we need to have the key management. So in the IPsec ME, there's a draft on how do we do the lightweight authentication. And that's it. And hope we think this draft is very stable, and we're asking for working group last call. Any questions?
Hi, Altana, this is Fumiraki. I have a question. How is this approach different from service chaining, which already determines a predictive path?
It has similarity in it. Service chaining is chaining together functions together. However, this one is about two different entities, right? You have enterprise between A and B. In a way, conceptually, you are chaining together gateway 1 and the egress gateway 10. However, this draft is really about how does the gateway not to decrypt the traffic coming from A, however, only authenticate the traffic from A, and then with the information encoded in the Geneve header to be able to forward it to the appropriate egress gateway. So there's similarity there, but the purpose is different.
Okay.
Okay, no more questions? Then that's it. Thank you.
So how many people in the room have read the draft? Okay, we will prefer more people to review it, and we can start some direct review at the same time. Get it ready for the last call.
Thank you.
Okay. Thank you, Linda. Just a reminder for people in the room, please sign in, use your phone. So you can ask questions, you can join the queue, ask questions, and more importantly, next time we have a large room like this. Fan, please go ahead, and you have control of the slides.
Okay, thanks. Hello everyone, this is Fan Zhang from China Telecom. I'm presenting the update of Young Data Model for IPv6 neighbor discovery on behalf of the other authors. And thanks to the comments and support from the working group, this draft has become a working group document. And now let's do a quick recap of what the draft is about. And for the young model for neighbor management, some work have already been done, like module IETF IP covers the basic ARP entry and neighbor entries, and stateless address auto configuration, and also DAD. And the submodule IETF IPv6 router advertisement covers router and prefix discovery. And we have another draft that extends ARP young model. So what this draft covers is the additional configuration and management of IPv6 ND protocols and its related functions that are not covered by the above young models, including IPv6 address resolution, redirect, proxy NA, neighbor unreachability detection, duplicate address detection, secure neighbor discovery, securing neighbor discovery proxy, and statistics of ND. And initially, we wrote the draft as correspondence to the ARP young model to cover the function of address resolution for IPv6. And we named the module as IETF ND first. But as AC pointed out during workgroup adoption poll, the model only covers part of ND functions and the name was not appropriate. So we made some changes and added more data nodes. And as I say, we add notes about IPv6 redirect messages and secure ND and secure ND proxies. And we changed the module name to IETF IPv6 address resolution and changed the prefix to align with the new module name. But as the draft now covers more than just IPv6 address resolution, we then changed the draft title to Young Data Model for IPv6 Neighbor Discovery, which seems to be a little bit contradictory. So we welcome any suggestions for a more suitable module name and the draft title. In addition, we made some editorial improvements to make the description more accurate. And any feedbacks and comments are welcome, like other functions that need to be covered in the model or a more suitable model name and draft title. And it will really help us to improve the draft. And as we mentioned, we have another draft of ARP young model that has been stalled for a while since its lack of IPv6 solutions. And its last several revisions made only editorial changes just to make it more readable and clearer, and didn't change the ARP young model itself, which means it seems to be stable. And since the draft of IPv6 ND young model has been adopted by the working group, we think it's time to move forward. And we would like to request working group last call for the draft of ARP young model. And that's it.
AC, please go ahead.
AC Lindum Lab and Networks. Can you hear me?
Yes.
Okay, good. So you added what did you add besides the neighbor discovery? I mean, not neighbor, the address resolution. You changed it back to ND?
we just add some notes about the redirect messages and secure neighbor discovery functions, some notes related to that.
So for the things that are in ND that aren't in here, aren't you just missing a couple some counters now, statistics for them, or?
We didn't include those like router discovery, prefix discovery, and something like stateless.
Yeah, router
stateless,
discovery already is
yeah.
someplace else. I think
Yeah.
It's in the routing model. I think it's or
Yeah,
it's in the same draft with the one that has the riv in it, or the same RFC. I mean, if I don't mind if you call it ND as long as, I don't know, it'd be good to do an analysis of what is missing to cover everything in whatever it is, RFC 43, what is ND, neighbor discovery RFC 43?
42, 41. Sorry, 48, 61, 48, 62, I think.
Yeah, it would be.
We're just trying to cover the rest of it.
If you're going to keep it just with what's in there and not all of it, at least there should be a reason why you're not putting the rest in, and that somebody else should be able to augment it and add the rest of it.
I think
or you add it before working group last call.
The last call is for the ARP Young model.
I know that. Yeah.
Yes, sir.
Dr. Lampert, did you test the send pieces in some actual deployment to see if there were issues with the model?
Sorry, we haven't.
I don't think she tested that. There might be running some tests through some young tools. That's it. Yeah.
Lou Berger, really trivial question, but I'm confused why it's called address resolution when it's v6 neighbor discovery.
Okay.
Sorry?
I think the original name was neighbor discovery. Is that right, Fan?
The draft title, the original draft title is Young Data Model for IPv6 Address Resolution, and we first limit the scope to just as a correspondence to the ARP, which is just for IPv6. And now as we adding more nodes, and it's not only about address resolution, so we changed the title to neighbor discovery.
But you didn't change the model or the module name.
The model was changed from IETF ND. The original module name is IETF ND, and during the working group adoption poll, ACE suggested that it's only about address resolution, so it should name IETF IPv6 address resolution, so we changed the model name. And I know it's a little bit conflicting, and we welcome the suggestions. So.
If the direction is to allow for and then add all the other elements that you would need to manage neighbor discovery, and if that's the direction, I think you should call the module v6 neighbor discovery.
Yeah, I agree.
Thank you.
Yeah, thank you.
And that's something for you to consider. I guess maybe we can review the original specification and see whether more content need to be added, and later figure out what's really the right name.
Okay.
Thanks for doing this work. So for the ARP Young model, we can probably start with, we have Eric, please go ahead. Yeah.
Not to disagree with Lou, but I guess first, my quick skim of this was that it was kind of looking like Linux proxys netconf interface config for just the address resolution parts. There's a bunch of other ND stuff that seems to be tracked elsewhere. And also ND has like information node query stuff and a whole boatload of things. So I don't know what the one group wants to do, like centralize it or split it up. But like there's a lot of extensions even now for things that fall under the name ND that are not actually neighbor discovery, but some other ICMP-based control protocol.
Lou responding. I was keying off of the comment from AC that they're going to add in everything for neighbor discovery. And if that's the intent, it would make sense to change the name. If they're, I feel like we're flopping back and forth here. And you got to choose whether you're doing neighbor discovery or address resolution. Pick and be consistent. That's my comment.
And I was thinking that because they had moved it, they had already said RAs and other things were somewhere else. Oh, they're coming back?
No.
Oh, no, I understand that, yeah, but the RAs stuff aren't. Israel is not coming back. Anyway, I don't know, but I just.
Those
yeah,
about
neighbor discovery is
RA
great.
has already been defined in IETF IPv6 unicast routing, I think. It's already in another young model, I think.
Yeah. This is AC. I'm in the queue, but I'm gonna break in. Yeah, I'm a co-author on not the original that just did the RA, but I am a co-author on the Viz version of that draft. So I know where it is in a separate module. So that
I think I agree that this is just address resolution, right?
Right, but that's well. Actually, they've added more. There's some counters for some other things in there. And if the intent is to add everything in there, it's fine the way it is. But it would be good to get as much of it, as much of the neighbor discovery protocol, because I don't think neighbor discovery is that insurmountable a protocol that you can't put it all in one model, other than router advertisement, which is already in an RFC. Anyway, I think we're kind of circling here.
Well, maybe we can take the discussion to the mailing list, continue it. Eric, are you done with your comments? Eric, are you done with your question?
Yes, thank you. Sorry about that.
Okay, thanks.
Fine, thank you for the presentation.
Thanks.
Yeah, thanks. This is good to get this done, despite my comments on what it should contain and what it shouldn't.
Okay.
Okay, we can go next. The next draft is, am I audible? Can you hear me?
We can hear you, Aditya.
Yes, please.
Yeah, thank you. The next draft is about the fast failure detection with the VRRP. This draft, if you go in the next slide, this draft has some history, which we thought it will help others to recall. Okay, I have the control, sorry. So this draft has some history. We did present this draft first time in IETF 113. There were two drafts which were parallelly going on. One was for BFD and one was created for P2MP. And then we also merged both of the drafts, presented, got a lot of comments, incorporated all the comments. But due to some reasons, due to IPR conflicts, we had to change the drafts. We have to move back to split the drafts into two parts. One became P2P and another became P2MP. And in IETF 110, we again presented the draft, and with thanks a lot for all the comments provided, and with all the comments incorporated in the draft, we had it accepted as a working group draft. This was a brief history of the draft. The problem which we are trying to solve here is pretty simple. In the data center networks, as well as with all the AI built networks nowadays, we are seeing all the applications or your AI pods, they require real-time failures. They want to have real-time applications. They want faster failures, as well as not just faster failure detections, but also faster recovery. So this drafts brings that both the parts. For faster failure detection, how do we integrate it with BFD? And faster recovery, how do we reduce the election by choosing something known as a critical BFD session, which is something unique about this draft. And also we also looked into various other things. How do we also reduce the control plane impact, because we can go ahead with the aggressive timers, but it puts a lot of toll on the CPU and other things. Um, with the problem statement, what does this draft brings? It brings a new packet type, which is a backup advertisement. We already have one advertisement defined in the RFC 9568. We are bringing another packet type in the VRRP, which will help us to distinguish between active and the most critical backup. Based on that, this draft also provides an algorithm with which we will start sharing the information or sending those backup advertisement packets. Once those are done, then we are going to build a peer table. Based on the peer table, we will know where the session is required. If you really see right now, the current implementations in the industry, the VRRP, since it doesn't know about active, only sends the packet. So the configurations wise, also this draft brings more of a auto configuration from a user point of view. They really don't need to worry about which one is the active and which one is the backup device. And then we internally form those BFD sessions. This is just a glimpse of how does the peer table works. We do exchange the information from active backups. And once that information is exchanged, then we start building the BFD session known as the critical path BFD, as well as we can build with the other BFD sessions based on if the BFD is able to scale on those devices. What is the work done so far in the draft? There is a extension to the protocol which we have defined. There is a new packet type. How does this peer learning, VRRP peer learning model works? What does critical BFD session? How does it help in the faster failure detection? There is a change in the state machine because we are bringing a new packet type and the exchange of those packets. Also, there were certain scalability consideration and operational considerations, which was brought during the working group discussions in the mailer alias, and we have incorporated all of them in the draft. Now, moving to what we have brought the last changes. Last changes is there is a new draft from VRRP point of view, which has been come. We have brought all the changes, whatever is proposed as part of RFC 9568, as well as the inclusive guidelines which have been shared. Those are the latest changes in the draft. We will like more engagement of this draft in terms from the working group and gather more feedback as well as bring a better solution. Jeff.
Hi, Jeff Haas. Wearing my BFD hat for once. Did the authors consider using seamless BFD rather than standard 5880 BFD?
Jeff, this draft, it can encompass all variants of BFD, because if you really see, we are not focused on point-to-point BFD or multi-point BFD or SPFD. You can use anything.
So the motivation for doing seamless BFD is that if you're doing standard 5880, single hop BFD, for this, you have to have a running state machine, and that's what looks like it's partially motivating this procedure in your draft to have this magic session. Whereas if you're actually able to do seamless BFD, what you're actually doing is addressing the device that happens to have the role, which might be under a current VR ID rather than a specific IP address. So this might actually get you out of the point of needing to have quite as much magic in the VRRP procedures to decide whether you need to fail over or not.
We do look into the seamless BFD in the recent times because there is another draft which came for the seamless BFD. So from that, what we understand is more like we can push some of the updates from the VRRP state machine toward the seamless BFD. Definitely, that is something which we can take a look. But as I mentioned, that whatever the peer learning model we are saying, that is very much specific to the VRRP. We can use the seamless BFD the way OSPF or ISIS or L2TP they have used to carry the those discriminators. That will definitely help in order to scale it well. So comments definitely taken. Seamless BFD can be considered for the scalability aspects as well as to clean up some of the state machine.
Right. And rather than worrying about the scalability, so to speak, you're at that point worrying less about having less state in VRP to enable BFD, and just focusing on the BFD procedures. You care about the role of, being able to fail over. You don't care about having a point-to-point session with the backup.
Sure.
Anyway, thank you.
Thank you.
AC, you are the next.
So Aditya, this draft, basically the backup advertisements are sent at a normal rate, and they're just to let all the VRP routers that are participating know who to set up BFD sessions with, correct?
Right, but we do think about that we don't want to send the BFD updates at the same frequency as the active, because it doesn't.
No, I understand that. So but it's more of a provisioning of the BFD sessions so that you can have this full mesh of BFD sessions among the routers that are participating in the VRID, right?
That is true. Yes.
Okay, that I understood it right then. Thanks.
Thank you.
Yeah, it seems like if you could avoid adding that and using seamless BFD, like Jeff was saying, I don't envision it right. That would probably be simpler, wouldn't it? I don't know. When I listened to him, it sounded like something to look at.
We started this work kind of before seamless MPLS came into picture. That's probably, but those are all valid points.
Prasad.
Vankanta.
Yeah. Prasad Govind, Cisco. Yeah, thanks for this, Jeff. Just a couple of things actually. In the slide 6 that you have, you mentioned 3 into advertise interval. I think it should be detect multiplier into advertise interval, right? It's not. I mean, 3 is the default, but you can have a detect multiplier higher or lower as well. That's a minor thing.
That is true.
Yeah. Second thing. Yeah.
When you reduce it or the granular you make the advertisement interval, the higher the load it puts on the CPU, and that is one of the reasons why we wanted to do in this way.
Yeah, sure, that's fine. But my point was, it's not hard coded to 3. It should be detect multiplier, right? Because BFD detect multiplier is configured. Yeah. Second point, I don't know, Jeff and Casey made about seamless BFD. I correct me if this is just my thought. I mean, no particular preference here, but I think BFD is slightly a better fit because of the fact that you have the neighbor signal capability. So even if you have a case where you have asymmetric BFD timers where one guy is fast and another guy is slow, for whatever reason, BFD could be a better fit in the sense that the faster guy detecting it can just signal the neighbor down and therefore essentially bring the session down. That's just the part.
Yeah, those things, yes, definitely. In that situation, the point-to-point BFD will be much better solution than seamless BFD.
Any other questions? Okay. Thank you for the presentation. Right now we have a BFD for point-to-point and point-to-multipoint, both in RTGWG, and now Jeff brought up the seamless BFD. So I think the chairs will work with the authors. We need some coordination work to make everything goes right.
Thank you.
Thank you.
Hi, my name is Zafar Ali from Cisco. I'm going to present this draft on SR policy programming RPC on behalf of my co-authors. So just first look at the problem statement. What we are trying to do is to define an RPC for programming of infrared state related with SR policies, and the application really required to be done in real time. To give a sense of an application, tactical traffic engineering is one such application where a controller wants to program a further state on the SRT head-end device to take the traffic away from some congested IGP shortest path. These are ephemeral state. If the router reloads, these states goes away, and that's by intention, that's by design, not as a bug. So there's no configuration as such required to be pushed for these type of programming states in the network. So if you look at from the SR policy aspects, currently there are means to do this, and one of them is protocol based, so PSEP or BGPTE, but that really means that the adoption of this to a controller really require controller to implement the whole full protocol stack, which is heavy duty. And then the controller also do all the laborious encoding, decoding, and serialization on the wire. So it does get into somewhat complexity compared to many RPC mechanisms. The other option is configuration, but I just mentioned that the intent really is these are infrared states, not permanent states on the box. But one other issue is with the configuration is that there is always configuration serialization, consistency check. So if a configuration which a controller wants to divert traffic from for let's say tactical traffic engineering is behind some other configuration happening on the box, then the timing for the action are unpredictable. So why we are here? So that the point for this draft is to discuss. The draft does not propose anything right now. It is for discussion for quote unquote what could be a way for us to do quote unquote IETF standard RPC to create, update, delete, and report if another state related with the SR with an SR policy. Okay, so if we look at the components of RPC, and then that would be even more clear on in the sense of why we're asking this question is that there is like if I'm doing an RPC, first thing I do is I need to select a transport protocol that could be gRPC, NetConf, RESTCOM. Not all transport protocol are IETF standard. I would define a data model for that. So this could be Yang. But then I need to decide to select a serialization method for this. This could be a protobuf, JSON, XML, and not all are done at IETF or IETF standard base. In particular, combination of gRPC with protobuf is getting quite popular in the industry. It's a bit slow. Okay. So from the SR policy, the good news is that the data model is very well defined. Whenever we try to do or try to define any kind of this mechanism, whether they mean configuration and all, the most difficult problem is to agree on a data model. This is where industry get stalled, and basically every vendor has their own, and then there is no agreement. But here we are in a very sweet spot. RFC 9256 clearly define SR policy architecture and its data model, and all vendors have implemented using that data model. So you have a policy which has a very well-defined key, which is head end, color, and point, And then you have that policy contain a set of candidate paths. Each candidate path have their keys, and if you think of it, RPC is going to be another protocol origin in the overall policy architecture in terms of being able to install a candidate path underneath the policy. And each candidate path can have one or multiple segment lists. Segment lists are shortest source routed path. They are encoding with using well-defined types of identifiers that are also in 90 defined very well in 9256. Binding seed notation is what is the entity or the label that is used to forward the traffic when it's steered over policy, or if traffic come with a binding seed, then it will be steered on that policy. So these constructs are well defined. So it's a matter of taking this very well defined model and then creating an RPC semantics on it. In this case, the RPC that we're talking about is to be able to, from a controller, so client is being an SDN controller, to a router, SRT headend. So the server is SRT headend, being able to create, update, delete, and get reports for policy. And the unit signaling is SR policy, so it contains, the message contains all the candidate path in the policy. And we take two modes of operation. One is transactional, which is a controller may choose not to create a persistent connection with the headend device and can program policy, but in that case, and go away. But in that case, it's responsible to the controller to remove that policy. Client was not going to, a server is not going to remove on his own. On the other hand, the persistent means client and server has a persistent connection. If the connection flap, then there is a need for the mark and sweep. So
You have 3 more minutes.
Okay.
So
yeah, so I'm going to go very quick on the messages, and because I want to get some feedback. But the open message just define the client IDs and timers and mode of operation. Policy request is a bundle message of set of policies that contains the very well defined data element. And the HA is based on start and end replay messages. And yeah, and the response is really what is the status of the request. It contains policy key and sequence number, so the client can identify what is thing. So again, just to remind, the main point to solicit here is what is the IETF standard way to document such an RPC. Thank you.
Boris, yeah.
Hi, Boris Kasanov. Zafar. So I think we need more like clarifications about motivation, because so far for me with arguments about serialization, for example, versus PSEP doesn't sound quite convincing.
Yeah, so I think I'd like to build on this. The motivation is really like, if you look at, if I'm, or you have a client that or a provider that wants to implement a controller, for them to ask you do the full PSAP stack or BGP stack, it's a lot of work. And whereas here you have a simple RPC mechanisms that you can use, and that is a lot less programming and that means far faster adoption by the user of these policy or these construct. And this is the reason why in the industry there's a lot of it's not the only way. Like, I mean, if you look around in past few years, we have implemented lot of these APIs, which is not protocol based and does the programming on the box.
Zafar, have you read? Sorry, you didn't finish.
Yeah, I understand, but so far we also have like PCAP libraries for Go, and we use it for controller. So we need more comparison, I would say, to highlight advantages of gRPC versus PCAP. Sure. For BGP, yeah, I would agree, but for PCAP, so far not.
It's fine. We can talk offline. Thank you.
Chair comment, please take a look at RC 8342 that defines ephemeral and DMA store. I think semantics are highly suitable for what we are trying to achieve. There are also a couple of comments in the chat in the same vein.
IETF. Andrew, please go ahead.
Andrew Stanokia, just a question, why the signaling of the SR policy as opposed to a candidate path? Because obviously PCEP and BGP uses candidate path for signaling, so why go SR policy as the unit?
Yeah, so again, if you look at the model, the entity, if you look at truly the data model, is really the policy containing the candidate path. That's the true data model. We started with the baggage with PSAP that we have LSPs for RSCPT, and the candidate path became the unit signaling because of that. But if you would defining an RPC, a new RPC, would we go and do that candidate path level? This is not the data model, but this could be discussed. I mean, Andrew, this is something.
I
But
disagree.
just the motivation to that, you know.
I disagree. It's a little bit of baggage. I think it just makes sense because you're often going to modify one candidate path at a time, right? If you're rerouting a path for a certain reason or you need to update something, you don't necessarily need to update the entire policy. So
yeah,
it feels like that might be a little heavy. So if there is benefits, by all means, like it'd be good to document that. But yeah, thanks.
So in here, the message will actually contain all candidate path, and you can apply the change set fully. So you don't have to compare with the previous one.
Oh.
I think I'm reiterating something that Jeff said, and I also said on the list is, I don't understand why the mechanisms you have on, I think it was like slide 3 or 4, aren't sufficient. You even presented there's Yang available to you, and then there's different transports, including GNMI, which I know isn't standardized here, but it's just gRPC. Why are those things not good enough for you?
I looked at many things, Luke, and I look your email as well. So many things there. Yes, I think you're right. I mean, so what you're saying is that if you define the Yang here is good enough, and then you pick up your transport, you pick up your serialization method, and that would be the way to move forward for us.
Yeah, I don't see that you're missing any semantics from what's available and widely available and deployed. I mean, if you want to go there fast, just use the existing infrastructure. Why do something new?
It's a fair point. Thanks.
Okay. I don't see more people in the queue, so.
Zafar, I think it would be very useful if you include comparison table in your document and compare new proposal to existing one, kind of pros and cons analysis. Why would we need something new, and what cannot be achieved using existing technology? It would be very useful for the draft.
Thanks, Jeff. We are purposely didn't include it just to not create a rat hole, but we can. Yes, thank you.
Thank you.
Okay. If no more questions, we'll move to the next presentation. Thank you, Zafar.
Thank you very much.
Hello. Yeah.
Yeah. Can you hear me?
I can hear you okay, and you have control of the slides. Please go ahead.
Let me see. Okay, I see the control. Okay. This is Izoli. I'm going to give a quick update on this draft. The draft talks about the challenges and requirements for routing in computing cluster network. So this is a little bit regarding the background. We are talking about the computer clustering network. this is a typical topology of it. So I'm not going to go to too much details here, but there are some well-known characteristics for such kind of network, like they are very large scale, there are multiple paths available, and admin normally knows quite a lot of knowledge regarding the topology, the available paths, and also the traffic patterns. And we expect such kind of network to provide very high bandwidth and low latency for very large data volume. And the last but not the least, the interesting thing is if we look at the bottom layer here, there are different parts. They are very high modularity based, but there are a handful of different topology, like a very traditional class, or they could be full mesh or like a 3 torus. But there are only a handful of this very modularity based part structure. So from this from all those well-known characteristics, the key considerations for routing in computing cluster network, there are three of them: the scalability and availability. The second one is the failure handling and the convergence. And the third one is the complexity for the configuration of the network and also the maintenance of it. So this gives a little bit regarding the background. So to recap, what we were trying to do is we were trying to find a good way to combine the advantages of both the distributed routing and the centralized routing. So there are different things we can learn from these two categories. Like for the distributed routing, the things we want to absorb include like the good scalability, because they are not rely on a centralized node of a few centralized nodes to do the computing and inform. And also the protocols like BGP give very good very flexible policy control. And at the same time, there are something that we want to reduce, like the high computing and storage overhead for each of the network node. If we are talking about the IGP, then each of the nodes need to store the whole information of the entire network. This is what we want to get rid of. And also, if we talk about BGP, then there are heavy configurations and also the slow convergence caused by the per node calculation of propagation. So this is what we want to absorb or reduce from the distributed routing. And at the same time, for the centralized routing, there are also pros and cons. For the good thing, they provide a global view so that it makes the optimal routing path calculation much easier. And there is either a no or minimum routing calculation on each of the nodes, because most likely the controller will do the computing work, and the configuration on each of the network node is right. These are the good things. And also at the other hand, what we want to reduce is there are always concerns regarding the scalability when we are trying to do the centralized based routing. And also there could be a single point of failure in out of band control network may not have the fate sharing with the data network. And the last one is the inefficient exception handling, because the controller may get involved, so it's not as efficient as a data path. So these are the things we want to consider in order to find a good way to combine the advantages of these two categories of the routing. So basically, we made some updates from version 00 to 01. Most of them currently the changes are the clarification text of it. So I listed here. We try to use the term hybrid routing for those for the routing mechanism that combine both of the distributed and centralized one. So we briefly in the document we briefly examined an example from a paper called Primus. So we think it could be a good starting point, because it gives the global views and also supports good scalability. And one of the key information here is it also trying to minimize the per node computing and storage overhead. It turns into the post-switch routing calculation into a manner of like a table lookup, and also using some kind of pre-installed basic topology and predefined rules in order to reduce this calculation overhead and storage overhead. So these are all we think that these are all good approaches for doing a hybrid routing. I mean this kind of concept. There are still things remained to be solved, like one of the important thing is the key strategy still need to be determined by the hybrid routing. How to properly divide the routing functions between the central controller and each of the individual network nodes. So there are different ways to define such functions. So the strategy, what's the best strategy, is still under discussion. And currently, we put some considerations for a hybrid routing candidate. So I'm not going to read the bullets here, but we think the key considerations, including what the controllers can do. But most likely it is helpful to provide a global view and traffic planning, and to make full use of all the prior knowledge. And also, but for the distributed part, it is useful in quick detection for the network failure and rerouting. And also, we think it is very important that trying to minimize the panel routing calculation, especially when the fault occurs to support better scalability. So what we are trying to do right now is that for the next step, we will revise the draft to elaborate this concept for the hybrid routing in more details. We think from the research paper, there are different categories of them. Some of them they try to name it like enhance of the SDN or enhance of some of the routing protocol. But in fact, we think they are all trying to do the hybrid routing thing. So we will try to collect the useful information from all this kind of research work, and try to figure out what's the best strategy to divide the functions for central controller and each of the individual node in order to better support the computing cluster network to meet the special requirements of such kind of network. So this is what we are trying to do, and we encourage people to read the draft, and you are welcome to join us. That's all. Thank you.
Okay.
What is the goal of the work? Is it informational reference for all of us of what people tried in the last, 30 years? There are many attempts to do this, or new routing protocols that potentially would lead to creation of new working group to develop it. What are you trying to achieve?
So currently we are trying to, it's informational first. So currently we're trying to see, because we think that the computing cluster network currently, for example, running the AI training on inference, they have the special characteristics different from like 20 years ago. So we want to try to collect all the information and use this document to provide an overall view to see whether it is a good time or it is the right thing to revise, to revisit whether we can make a different strategy or come up with a better strategy to do the hybrid routing. So that's the current goal of this document.
So I would think you need to take similar approach we did for routing in data centers. About 4 years ago, we've kind of community effort, we've written a draft that would specify requirements for a routing protocol in data centers. This resulted in Rift and LSVR working groups. Both are successful, their protocols deployed. So again, unless you want to create kind of reference courtesy
Okay.
of you and co-authors to read it. I think you need to start with going and specifying what's missing, what's not working, why this work is needed. So the motivation, not just
Okay.
there's this cool thing we need to do.
Oh, okay. Thanks, Jeff.
Boris, you have a question for this presentation, or you forgot remove yourself from the queue? Okay. Izo, thank you for your presentation.
Thank you.
Okay. Hello. Yes. Yeah. Good morning, everyone. Here, Tianji, here on behalf of the co-authors from China Mobile, Peng, and myself. This is talking about the routing in satellite networks. It's regarding just the use cases, challenges, and considerations. So basically, it's at the beginning because we got motivation from the to be honest, right, from the 3GPP point of view about all the use cases that's being discussed and have been standardized and or is ongoing to be standardized in different releases like a 5G and for the future 6G. So for those use cases, there are a lot of works and there are a lot of assumptions. In that SDO, they consider those out of scope, but here actually is in scope or it should be considered by IETF. So that is something that motivates us to do the work. And then also there's some circulation, circulated discussion on the RTGWG email alias about some routing technologies on this type of more abstract domain or related point. That's why we want to give a talk on this RTGWG session. Yeah, this is just starting like this. Okay. So I will just go with some use cases, but the first one is risk 18 that was like it's concluded already 2 years back in Berlin. Is in that moment, it's satellite. Well, there's one satellite. It will be like transparent relay. There are not much very exciting functionalities in terms of like layer 2 or layer 3. It's more about the layer 1 functionalities like the frequency conversion, channel conversion, and RF filtering information, those type of things. So it's not exciting here. So this is just the release 18, but 2 years back from the release 19, the satellite will be considered as a regenerative forwarding. So basically, it's start to get the layer 2 and the layer 3 here. So if you look at this, yeah, no, that's not work. Okay, well, it does not work. All right, okay, that's fine. So the things like the top picture is just a show from the left side. You get your mobile equipment with service link talk to a satellite, but the satellite itself may not be able to simultaneously access through the feeder link to the ground station. So it has to through some ISL links. And then in the picture, the bottom left, well, I think the PDF got some corrupted here. The bottom left and bottom right, there are two use cases that has been documented in the 3GPP document about the UE equipment like your iPhone, and then and also talk to the ground station through the different they are in different locations. So for that case, because the service link from your phone, your UE equipment, and the feeder link from the satellite to the ground station may not be simultaneously available. So in that case, the ISL part will play into the picture. And the bottom right part is something like you can see on the T0, I think. T1, sorry. The T1 time, their UE sends a message, but the satellite is not connected through ground station until the time T3, that after the half circle about the Earth. So in that case, it's going to talk to the ground station, and then the sun work like this. So what the emphasis here is ISL is important, is critical. Although the 3GP document say, okay, that is out of the scope. So the ISL is important. So I would just use two documented use cases from the 3GP document to say, okay, ISL is important. Okay, here is we have put the details about, okay, well, when people think about, okay, this is the orbit. When a satellite circle around, come back after one round, it's going to cover the original location. It's covered before it circle around. So actually, it's not. We put all the details about the calculation. Here we use some a number. You know, the conclusion is after one round, the satellite will be deflected about 2,000 kilometers. So the RAM cannot do that coverage after one round. Okay, it's just the details are in the draft. Okay, here is some ongoing work, or it's being done about here. Just to talk about multi-orbit satellite access for service continuity. It basically consists of multi-layers, like a LEO, like a MEO, and a GEO. And we list the three scenarios from the left side. The scenario number one, the UE communication came through the LEO. So basically, they're covered by the same single LEO. And the next one, the middle one, is just like both UEs are not covered by the LEO, but can be covered by the MEO satellite, or they can be covered by two LEOs connected through ISL links. And then the next one, it got like all the more complicated, and with the LEO, MEO, and the GEO part with some multiple ISL things. So all the use cases so far, they've been standardized and are going to do the standardization work. Okay, talk about, okay, ISL actually will be important for the connectivity. Okay, after all the use cases, how much? Okay. So after all the use cases, we have some challenges. Like we all know, it's very dynamic of routing a topology, and also we know the harsh environment, and also how expensive to launch some load toward the satellite. Okay, so the limited bandwidth of the peering links, and also the hardware limitations of reduced capabilities. When we consider all that together, we have a lot of challenge for routing part. Well, I'm not going to read this is a crowded slide, but you can count the routing convergency, calculation, LSD sync up, computation load, all kind of things. So it's all the challenges for this type of a scenario. And we have listed some routing consideration. The details are in the draft. But remember here, there's a uniqueness, like the predictable and the predetermined satellite. I think the previous author mentioned some pre-installed topology here. But the satellite, it has like predictable and predetermined footprint called ephemeris to help with the guidance of the routing or switching part. And here, I list one use case in the first big bullet about the 5G predictable set-based probing here. There's some routing consideration I'm not going to read through. And this basically is just to say we need some new routing technologies in order to handle these unique scenarios. I think that is oh yeah, I want to leave some time for discussion. So I will not go to the detail like 1, 2, 3, 4, 5. Actually, there are more about considerations. Yeah, so I will just stop here to solicit the feedback or comments, from audience chairs. Thank you.
Any questions in the room, online? No.
What do you expect IETF to do here?
Yeah, exactly.
I did not get the question.
So what do you expect?
Okay. The thing is at the very beginning, right? I talk about their circulation about to do some routing, new routing, those type of things. And then this is really new scenarios here. Well, we have to. I think my expectation is from RTG say, okay, to promote some new technologies like the routing part, but start with the problem statement and the use case or requirement part. It's not on the solution. There are many things that can be done here. So like even for the I don't know, like a layer. We mentioned about some reduced here some no full set routing intelligence on board satellite got the limitation, and also some predictable and predetermined satellite footprint that can help with the routing RTG work. That is, I didn't read all the details, but there are a lot of things RTG can do.
Eric, please go ahead.
I guess I was going to ask sort of a follow-on or related question about what you expect the IETF to do. Why would basically PCE or PCEP, SDN using PCEP not work or not suffice? Or what would be missing from a solution that wanted to use that?
Okay, Eric, that's a good question. I have to touch, some possible or potential solutions. So, in my mind, we want to get some soft-based routing here, because we want to get all the, routing intelligence to be on the ground in order to calculate some path, because the satellite has predictable and predetermined information to help with the PCE or the head end to do some sort of work. But that information or intelligence has to be through some way, like a routing exchange, signal exchange, to send to down the ground part to do the work. So that is the thing. I have to talk the potential solution here. Sorry. Yeah.
Right. So one of the things that is seldom brought up, I think, when these satellite things come up in the IETF context anyway, is that all these satellites already have a management plane. They have usually some kind of S-band, TT&C channel and whatnot, right? So these things are already being controlled continuously and monitored continuously from the ground. And I'm not saying that a network operator would want to reuse that to relay PCE messages, but it could be done.
Yes, but here you mentioned about the on the ground part. Remember here, I keep saying like if you have a multiple satellite above, and then they have to talk to each other, right? Things like there are some things they have to exchange, like layer to layer, because so far 5G or maybe for 6G, they're going to use the IP part. So that is actually something here. Not here actually I did not mention about, they talk about the 6G. They have some 6G vision from more than 30 companies about the UE will talk to multiple satellites above, and those will get multiple passes, like MP, like multipass, and also for each path you get multiple satellites. So this is a more complicated case. Yeah.
In the UE case, though, isn't it directed which one to hand off? There's going to be something. From
No, it's not like hand. I'm not talking about the radio part, and not just to say, okay, this is something not going to be discussed from the day one for 6G. The UE can directly talk to multiple satellites part, and then that is like, and then for each satellite going to the ISL link toward the next, and merge at some point and go down to the ground station. So it's I'm not talking about the radio. No, not radio at all. Yeah.
Oh, all right.
Thank you, Eric.
Jeffrey?
Jeffrey?
Oh, okay, Jeffrey from Juniper. So you use the 5G, 6G use cases to arrive at those conclusions or the challenging on the routing aspects. I'm not saying those challenges are not correct. It's just that those are generic problems to solve in the satellite networks. It's not specific to 5G or 6G at all. So once we solve the general problem of routing among the satellites, the 5G, 6G problems are also solved as far as on the transport side. The 5G, 6G itself may need to do some work, which you and I are actually pushing on their side. But as far as on IETF sides, we have a generic problem to solve, basically routing among highly mobile and limited capacity. With those challenges, those problems we need to solve. But those are generic problems.
Okay, thank you, Jeff. Agree. Tony?
Hi, Tony Lee, Juniper Networks. To your point here, I sort of agree with Jeffrey. The problems that we have here are about dynamics and scale. And there's really nothing new needed here for routing. Okay, this is a topology. The fact that it's in space is almost irrelevant. Okay, it just has some interesting properties in terms of dynamics. Links are flapping way more than what we're used to. Okay, but there's ways of solving that, and we don't need more technology to address this. Okay, we have a proof of concept of one possible way of doing things already. To Eric's point, SDN is something of a problem. Again, we have a dynamics issue and a scale problem. If you can imagine a constellation of 40,000 satellites and you're trying to refresh the fib in all of those satellites from a single point, and you're concerned about your uplink bandwidth, you've got a problem.
Yes, Jeff, sorry about that, Tony. Thank you. You raised a very good point toward the end. If I have more than 4,000 or 5,000 in my constellation network, I have to do the LSDB, all kind of the flooding part. Actually, we don't want to that thing. That's why in the routing consideration, the first point is no full set routing intelligence on board satellite. We try to get some reduced or simplified things for that part, and then to integrate with the TN network. Yes, thank you for raising that things.
Tony, you want to mention something about the work being done in TVR?
No, I don't.
Okay.
This has got more to do with RFC 9717 than TVR.
Okay.
But I, again, agree completely that a distributed solution is far more preferable than a centralized solution here.
Okay, thank you.
Okay, thank you.
Thank you, Chair.
Can you hear me?
Yes. So
Thanks.
you have 8 minutes for your presentation.
Okay. This is Chang Wanling from H3C. This draft is about IGP color awareness shortcut routing. So background, IGP shortcut as described in RFC 3906 enabled IGP to calculate the routers over T tunnels. The IGP shortcut is based on nodes. If the first hop of node is determined to be an T tunnel during SPF calculation, all the router to IP prefix advertised by that node will be over that tunnel. So in some scenarios, there may be requirements to steer the routers to different prefix of the same node onto different T tunnels. So this draft describes the enhance of IGP shortcut, which can steer the routers on T tunnels based on the prefix color. For example, we consider the following scenario between route 1 and route 3. There are two SR policies. SR policy 1 with 100 color corresponding a low latency LSA, and SR policy 2 corresponding to a high bandwidth SLA. In case of traditional T shortcut, all the prefix will point to SR policy 1. For the color weather routines, the next hop for plague 1 and plague 3 will point to SR policy 1, and plague 2 and plague 4 will point to SR policy 2. Here is the solution overview. The proposed solution outlined in our document is to use the color IGP prefix and steer the color prefix over color matched tunnels. In the mentioned scenarios, we can assign a color of 100 to prefix 1 and prefix 3, and a color 200 to prefix 2 and prefix 4. This way, when route 1 performed the IGP shortcut, it can match the SR policy based on prefix color. As a result, on route 1, the next hop for prefix 1 and prefix 3 will be SR policy 1, while the next hop for prefix 2 and prefix 4 will be SR policy 2. We reused the IGP route tag to carry the color, so there's no extension for IGP protocol. We want to update the SPF calculation of IGP shortcut as described in RFC 3906. Add the following steps when calculate the next hop for prefix advertised by a node. If a prefix is colored, we look up the first hop information of the advertised node for T tunnels with the same color. Here is the use case for SRv6 locator based on IGP card shortcut. BP advertised the service route and will SRv6 service it. Within these three Austria areas, IGP shortcut calculation are performed. And each Austria area, when the IGP shortcut calculation performed, we can use the prefix, the locator's tag to match the SR policy. So for the forwarding plane, the traffic in each area corresponding to the colors SR policy. We can take a look about our draft update and state. We presentation at the IETF 119 and 120 in RTGWG. We discussed with chairs of ELSA and RTGWG. So we moved this work to RTGWG and we removed the IGP protocol attention and changed this draft to informational. Our draft focused on update the IGP shortcut as described in FCA 3906. We think the current draft is stable and focused on the IGP shortcut based on prefix color. So we are seeking for adoption in RTGWG. That's all. Thank you.
Jeffrey and Tony, do you have questions or you forgot to remove yourself from the queue? Maybe we start from Peter.
Peter Pshenak, Cisco. So I'm happy to see that you removed the IGP extensions from your draft. But then the question is what has left? I don't see much. All you are describing is on the tunnel head end, what is your steering policy into the multiple tunnels going to the same destination? I don't particularly see why do we need any RFC on this. It's a local behavior. You can do whatever you want.
Yeah, thank you. In IGP shortcut first described in FCA 3906. So this very old FCA, we just want to update this FCA. When we call the IGP shortcut, we can use the tag of IGP prefix to look at the colored SR policy.
But that RFC doesn't specify how you load balance your traffic across multiple tunnels to the same destination, does it?
This RFC just not mention the tag of prefix will look up all the T tunnels. We can't
Right.
select.
For a good purpose.
Yeah.
They don't want to solve that problem because that problem is the head-end implementation. All right, thank you.
Yeah, thanks.
Yeah.
Thank you. Just to continue the discussion from Peter, we have checked the RFC 3906. There is some description for the shortcut calculation, both in the SPF calculation part and also the routing calculation part. So we think that maybe we have changed this description. So we want to hear the advice from the RTGWG. Thank you.
Any other questions? I think we need more people to look at this document, see whether this informational thing needs to be specified. Okay, thank you, Changwang. So we'll go to the next presentation.
Hello, my friends. So I'm Charlie from Huawei. Today my topic's about AI for network operations. So thank you very much for my co-authors and contributors from Siena, Cisco, Huawei, Lancaster University, and DT, Telefonica, and TELUS. Yep. Next, please. Controller.
Yeah, try it.
Yes. So basically, it's a common sense that we may have several aspects consider of AI and network, right? So first of all, you can see we can have network for AI, and then we have AI for network. Even we have AI for engineering, right? So our work is focusing on AI for network. Uh, Here's some general idea of what is AI NetOps, right? So basically, we will have like some data. We call it big data. You can call it big data, and we have some AI related processing algorithms such as machine learning, right? So when you combine the data and algorithms, you would have some so-called AI like tools, right? So which can bring you some benefits in your like operation and management. Yep. So that's the topic of my presentation today. Yep. So here's some basic information of what is AI. I will not go into the details, and basically everyone knows what is AI, what is machine learning, deep learning, right? So next, please. Yes. So here's generative AI, which is the hottest topic recently, and you can see the logic of how it works, right? We have some. Well, we have one so-called like Gen AI model, and you can input some series such as the text, the video, the image, right? So you can get some generated output. Yep. And we list some of models here. And come back to the topic of our document. The go how say the topic of our document is about AI for network operation. So we basically list some benefits and scenarios of AI for network operations. Yep. So as you can see here, we have some goals in the documents. So first of all, we would like to explore what the roles of IETF and IRTF in AI for network operation. Honestly, I would say it's really hard to find some concrete IETF work right now. We have held several, side meetings to discuss what can we do together regarding the, AI for network operation in IETF and even IRTF, right? But it is true that it's really difficult. So that's the reason why we come here to share with you what we have done right now, and we can ask for some review, comments, and help, even contribution from you guys. Yep. And the second goal is that we defined, the conception of what is AI for network operations, for network to provide some, operational benefits. And in the end, the goal of the draft is to, guide the evolution of ITF protocols to support the AI for network operation. Yep. So here you can see the table of contents on the right side. We basically have 4 or 5 parts. So for the section 5, we list some benefits you can have by using AI in your network operation and management. And in the section 6, we list at least 21 use cases right now. And you can go to read the document to see which use case you agree on, and we can have further discussion and we can have cooperation together. Yep. And more use cases are welcome. If you have any like inputs, ideas, let's talk offline, and maybe we can come up with some, fancy, amazing ideas together. Yep. So regarding the scenarios or use case, whatever you call it, like we basically separate them into three categories. So first one is about assurance, and second one is about optimization, and the third one is about automation, right? So talking about assurance, we basically can have like 6 to 8 around these numbers use cases, at least in the document already. So I will not go into the details because there are lots of text right now, right? You can go to read the document. And about optimization, I would say it's quite typical because in the early age, we have been using, machine learning for optimization for a long time. So this one would be common for you. Yep. So with the data, with the AI algorithms, we can, combine with the existing tools so that we can generate some, automation operation and management. So that is the final goal for the AI for network operation to me. Yep. So here's some multi-agent LLM based dynamic network workflow. Basically, we can combine multiple agents together to provide different services for your network operation and management, and we can input multiple types of information into the system, and then you can have some required output, which can be the instruction to some existing tools, so you can support use the AI to support your network operation and management. Yep. And the most important point is that what's the next step of this document. So that this is also the important reason why we come here, right? We come here for seeking help, we're seeking for review and comments and even cooperation and contributions. So the first point is that can we sync up with some AI op network op related document in RTGWG? If we do have some similar documents here, and maybe we can discuss and see what can we do together. Yep. And the second one is that we're not really sure that here RTGW working group is the right place for this document for discussion, or moving forward. I'm not really sure, so we are coming here for asking your comments. Yep. And beyond this, we will have a presentation in MMRG tomorrow as well. We will discuss or introduce some further actions, such as the research of Gen AI agent or research of the multi-agent scenarios. Yep. And I see Tony Lee. Go ahead, please.
I'll start before Tony, if possible, as a kind of chair comment. There's an MRG working group in IETF. They have been working on these topics for at least 3 years. There's a whole bunch of drafts that are progressing. That's exactly the place to have kind of more of theoretical discussion. I don't think they're talking about agentic AI specifically, but applicability of AI to network operations for sure. This is RTF. In IETF, we've got NMOPs, whose charter is really management of the network, but standardized and the standard route documents in IETF. I believe there's also some discussion with regard to applicability of AI machine learning technologies to network management. So that's the right places to go to. Tony, please.
Yeah.
Okay. Thank you. Thank you, Jeff.
Tony Lee, Juniper. Our company does some AI, so I'm not supposed to diss AI despite the hype, but I'm going to. Is there some reason why you can't use the existing network management interfaces that we have? We've spent several decades working on this. We've got human intelligence using this. We've got automation using it. Why not use it?
We don't refuse to do so.
Okay, if that's the case, then what is it that you need to standardize?
Yeah, that's the point. So see, the last point is that we are trying to find some concrete IETF standard work of AI for network, topics. We're still
Okay,
finding
well,
that.
it sounds to me from everything you said that you're going to plug into the management plane and be done. And you're not going to use anything except established protocols. So there's no work here for us.
Okay, thank you for the comments. Yeah.
Hello, Reza Rokui from Siena. I'm one of the authors of that.
Do you mind to close the mic a little bit?
The idea of this draft is first bring the attention that there are some aspects that we want to do regarding the bringing various aspects of the AI, ML, Gen AI to networking, especially for management. And the question that Tony just asked is exactly whatever we try to do. At the end of the day, maybe the answer is there is really nothing to do. Everything that we already have is already addressed, and they're just using those models, protocols, data model that we want to use for this. Maybe this is the final answer. But the idea here is we don't know. Nobody knows the answer. We want to use the artifact is already created at IETF in our benefit. End result is there any gap? If the answer is yes, we are going to address it. If there is really nothing, we just exercise the existing model and we are advertising it to the operator to use it. So this is a very open question. It's not the answer per se, but this is something that we want to explore together.
Yes.
Hopefully that answers your question, Tony.
Thank you, Reza.
Thank you. That sort of answers it. I guess I would come back and say, we think we have a really good or pretty good management plane at this point. And so if there's something lacking, we'd like you to tell us. Not seeing any problems right now, and unless there is a problem that you're finding, I think we're done already.
Thank you.
Daniel?
Hi, Dan Lancaster, full disclosure, also sort of editor / contributor to the document. So a couple of quick points. First of all, don't panic. The 21 or so use cases, we will filter into the use cases that have critical mass. So what we're looking to do at the moment is identify the applicable scenarios that are being either deployed or considered to be deployed, and focusing on the top 3, maybe across a couple of those categories. To answer sort of Jeff's point earlier, the majority of content in this document really is short-term engineering. It's what's either been deployed already or in the process of being deployed. And to pick up on the Tony and Reza conversation, it's really about existing IETF technology, how it's used, are there gaps, what are the gaps, what potentially needs to happen in order to address those gaps. And already we've seen with some of the Gen AI elements, which have multi-agents, existing sort of management plane technology isn't sufficient. We may need to look at something else. Co-op has been mentioned yesterday during our sort of AI in the NE meeting. And then the content in the document that's more kind of research focused and therefore in the purview of the NMRG will be removed. Thanks.
Thank you. Thank you, Dan.
I don't see you in the queue. So,
Me?
Yeah.
I'm in the queue.
Please speak your name or.
Sorry,
I
my
didn't
name is
see-
Michael.
Yeah, okay.
It was nice idea actually for me, but have you considering about the sandbox environment before you applying your generative AI policy, routing policy or something? Because many of cases that I got when I trying to narrating and maybe creating some routing policy from AI, some of them maybe they have wrong configuration or something else. Maybe if you have some consideration to making sandbox environment before applying to the production.
Good idea. I think Reza could like to take.
Okay, I will answer that. Reza Rokui again from Siena. The idea of using a sandbox will be one of the potential use cases. The idea here is if we want to trigger something to the network, before doing that, we have to do some sandboxing to see that remedial action that we want to do to a network is correct or not. So that is a kind of orthogonal to the overall, but the concept that you mentioned definitely makes sense. Another level that we can bring to this one, and I didn't put it there, we will put later on, maybe it's another draft, is the idea of the digital twin network and AI ops, how they are related to each other. Because when you talk about sandbox, that is one of the use cases of sandbox, that you create a digital replica of your network in your sandbox, you do some of the processing, and basically after that you trigger the network. So in summary, it's a very good idea, but all this thing is something that this draft try to address. And as we go through this process, we learn from each other, and the whole idea is there any interest from routing group to do this? Is this the right place to do it? And this is mainly triggering question rather than answer. Thanks.
Thank you.
Thank you. I'll kind of split personality. First answer as a chair. Again, NMRG has been working, there are at least 3 drafts on digital twin. A lot of discussions. It's a well-developed topic, so I would really advise you to do this in NMRG. I'm not saying that we shouldn't be doing it here. I'm saying that there's already a lot of discussions, and work has been going at least for a couple of years.
Yeah, we will have a presentation tomorrow, right?
Yes, there is I will present there, and also we will discuss that from tomorrow, how it's going to work. But I'm just brought that to the attention that we are going to discuss that. Most likely NMRG is the first choice for this work, but we want to bring it here as well to just trigger some question, as I said, rather than answer. Thanks.
Yes, indeed.
Then comment as a working group participant. So please do split kind of unsupervised learning from formal verification, any kind of statistical analysis. This is pure math, been doing it for 20 years, deployed at scale at every hyperscaler, nothing really to solve unless you want to talk about this. The real value, and again, I'm working on this stuff pretty much on a daily basis, so I can probably speak about this. The existing NBIs and SBIs we've developed in IETF are good. They're working. They allow us to get data, plus, GNMI, other interfaces that are developed by OpenConfig that allow high fidelity streaming telemetry. So all of this stuff is there and working. I don't think we need any replacement or anything better than that. What we really need is correlation of events. Because events, it's really multidimensional, right? You're getting many events coming from different things. They're very different to correlate. It's difficult to correlate link flap on one side of the network with CPU load going up on another side of the network, right? So the real value of this work would be kind of definition of how to correlate event, and potentially, if we are going into machine learning, how to cluster them, use kind of standard clustering methodology. We've been using machine learning for years. This is where really the value is, right? I don't see any need for new NBIs, SBIs. They're working, and
Tom, please go ahead. Yeah.
Hi. Yeah, this may be partly maybe controversial, more of a comment. And I know this isn't a dispatch meeting. The type of work that you're doing, or I think what you're aiming to do here, is probably, I feel similarly to Tony, it's not protocol work, it's documentation in many ways, like looking at what the status quo is, looking at what the state of the art is, and documenting what people are doing and what's correct and not correct, but at the very least, how we should go about doing these things. And they are interesting things. It does feel like it's a little bit more downstream work, maybe not IETF or IRTF work. It's potentially something that's more suitable towards ITUT, one of the study groups, maybe 13, or ETSI, or something along those lines, but downstreaming from the IETF, where we've built everything. There's a lot of stuff going on in the industry. and then tying to people together and saying, okay, let's standardize how we do this. I think that could be worth looking at. I think.
Yeah, it's a good idea.
Yeah, thanks.
Thank you. Thank you for your input.
Dan, please be brief.
Very brief. So the comment was made in the chat that people have found the document quite useful, maybe as a cookbook or a piece of literature. I'm not sure if that's sort of dark fiction or popular culture at the moment, depending on the use case. Regards to Jeff's previous comment, one issue that's been identified over a couple of the meetings that we've had during the IETF is that operators need to understand how some of these AI reasoning solutions have come to the conclusion that they have, what they consider to be optimal or near optimal or a good response. We need some kind of visualization. We need to understand how the engine has actually reached that conclusion. And that's something that we're looking into as well.
Thank you.
Most new models expose reasoning steps, so it's built in.
Thank you for the presentation and all the discussions. So we have 4 minutes and we have 2 more if time permits presentation. So we can only do the first one. Sorry for the second if time permits presentation. We cannot go to that one. This one.
Hello, everyone. I'm Xinxin from China Unicom. And my topic is the scenarios and gaps towards to our generous IPv6 channel. And co-authors from Huawei, China Unicom, and the Agriculture Bank of China. First of all, let's take a brief review about this work. We studied at the 2023, and last year we updated to the version 2 and supplemented the requirement analysis. And also we clarified the our motivation. And this time we have revised the draft scope, which is focused on the scenarios and requirements. So in addition, I want to share about some deployment cases in our actual network. They have the similar requirement such as the Internet of Vehicle and the private line and the SD-WAN and so on. They also need the end-to-end differentiated service assurance and also the end-to-end in situ OEM across the whole connection. But in our deployment cases, we made some problems. For example, subtender servers in disruption and increase about the service latency. We cannot locate their problems, and also we cannot prove ourselves because there some tunnels cannot support some future capabilities such as the institute OEM and so on. So we think there is the common issue their tunnels technologies in these scenarios are relatively old, and they do not support their modern features. So we should to solve these problems. So we think the requirements about this and the scenarios are do exist and are clear. So we think it is necessary to do this work in the IETF, and we hope the scenario and the requirements document can be adopted this time. And yes, that's all. Thank you.
So any questions? Let's actually try this. Let's do a show of hands, see whether you think the working group should even work on this. Yeah, since we have 1 more minute in the session. Okay. So right now the yes is pretty much equal to no plus no opinion. Okay, so thank you for the presentation. So hopefully you get some feedback. You can continue the discussion on the list.
Yes, thank you very much.
And with that, I think we are at the end of this session. Thank you everybody for attending, and we'll see you in Madrid next IETF.
Thanks everyone. See you in Madrid.